we were discussing our testing, software testing, and we saw what is software testing and what is a software test case, where we saw that test case is set of conditions or variables under which we test our system, that whether it satisfies our requirements and works correctly or not. So in other words, we can say that our test case is a specification of inputs, execution conditions, testing procedures, expected results that define single tests to be executed to achieve a particular software objective. What is the objective of testing? As I told you before, that objective of our testing process is to find bugs, or you can say some errors also. Error means the logic is not correct. Bug means it is undesired. Of course, it won't be, it might be working fine correctly, but the output it is generating is not the required one. We want something else. Anyway, you can consider, technically error and bug are different, but you can consider them same for this for the sake of this chapter. So we designed different test cases: test case 1, test case 2, test case 3, under different environments, under different conditions, under different input variables, and we test our software. Which test case is said to be the good one? The one which has which is designed to find the possible undetected error. We are not, our target is not to ensure that the software is working fine. Our target is that if there is any possible error, we should be able to find it. If we design a test which is designed to find a possible undetected error, that test will be called a good test. And if it finds, actually it uncovers an undiscovered error, that test will be called a successful test. Yani you run the test and you found some bug in your software. That test is called successful. Why this terminology, good and successful, we have introduced here just to make your orientation that the objective of testing is not to ensure that the software is working correct. This is not the target. This is the ultimate goal. We definitely we want to ensure that if there is any error, if there is any bug, if there is undesired behavior, we should be able to find it. That is the target basically. What is testing and what is not? Testing is the process to find semantic and logical errors. You will be doing testing when your software is running. It means there are no syntax error. It means there are no programming errors. Because your software is running, that means so the syntax is correct. That means all the programming that is done correctly. But maybe the logic that you have introduced inside your software, that is not correct. Maybe the semantic that you have programmed, that is not correct. For example, a very simple example of logical errors could be that you wanted to add something, but mistakenly you subtracted it. Or you wanted to multiply something and you added it. That is one logical error. Maybe the formula you wanted to program, that formula you wrote something incorrectly in the software. Software is working, but the logic, because the formula you input in the software, that was a mistake. So that kind of, this is one example. All those kinds of logical errors and semantic errors, those must be found out. Testing is not aimed to find the syntax errors, yani your program errors, because testing is done when your program is running. If your program is running, it means all the syntax errors have already been found. So testing can reveal the presence of errors, not their absence. Okay, this is wrote in a good way, that we don't want to reveal that there is no error. We want to reveal if there are errors, those should be revealed. So we should design our test to find out these things. Okay, very interesting slide. Sometime there is another term which is similar to testing, that is called debugging, and some students they confuse debugging with the testing. So here are the differences between debugging and testing. All of you please read with me. A bug is basically an error or a flaw or a fault in the computer program, or if that program is a part of a bigger system, so we will say that this is an fault, this is error in the system that causes it to produce an incorrect or unexpected result or to behave in an unintended way. We didn't want to behave it like that, but software is giving us some different output. That output, which is undesired, unintended, is called a software bug. Okay, software is behaving in a strange way, in a different way, in an undesired way. It means it has a bug. Next process to find the bug is testing. Testing is the process to find the bugs and errors, that we do something through which we come to know that there is a bug. There is a software bug inside our software, inside our program, inside the system we develop. We did something and we found it out. That process is called testing. After testing, what do we want to do? We want to correct the errors. The process of correcting the errors that we found in testing is called debugging. So we do testing first, and then the process of correcting the errors is called debugging. So testing comes first and debugging comes later. Why software testing is required? Very simple answers and very important. These few slides are very important, I would say. You will realize the real importance of software testing. Software testing is a separate activity in software development life cycle, and we require it because of the several reasons. The very first reason is that testing provides an assurance to the stakeholders that the products or the software that has been developed, it works as intended. It is doing our functions, stakeholders' functions, as they were expecting it, as they had given the requirements for. Here comes a very important term, stakeholders. I have already explained this to you in the class. What do we mean by stakeholders? Stakeholder means all the people who have interest in our software, who have some associations with the software, who have some advantages or disadvantages associated with software, who have some links, some relation to the software. All the people who have paid for it, all the higher management who have paid for the software, they are the stakeholders. All the people who will be using the software, they are the stakeholders. All the people who are involved in designing, developing, testing the software, in all software development life cycle, all the people who are involved in the development of the software, in all the steps of the software development, they are also the stakeholders. So testing provides an assurance to the stakeholders that software is working as planned. So this is kind of a quality check, quality assurance of the software. A happy software makes all the stakeholders happy. The system analyst, he will become happy if the software is happy. By happy software means it does not have any bug. It is working as it was planned, as it was expected. If software is happy, then the original developers, they are also happy. The project manager will be happy. The end users who will be working on the software, who will be using the software, they will be happy. Their top management, they will be happy. And the IT supporters of the software, they will also be happy. Okay, so these are major stakeholders which were involved in software development. End users, he will be involved when the software is developed. Actually, he will be involved right from the start, because we will be, as software analyst or system analyst, you will be in contact with the end users right from the start so that we collect their direct requirements. In summary, these are the major stakeholders. They will be happy when the software is working as planned. In this slide, that software is called happy. Second, major reasons to do the software testing is to avoid defects or the problems before the end users or the customer they come to know that. Because if some error or bug is revealed by the end users, of course they will be very unhappy, of course they will be very frustrated, and this will create a very bad reputation for the development company. And you know, nowadays this is the age of media. We are all linked together through a lot of social platforms. If some reputation goes bad, it affects drastically the company or the people who are involved. Some more reasons of doing the software testing, you will see inshallah that we are doing we should do, or basically we have been doing some kind of testing, some kind of assurance, some kind of validation during all the of our software development life cycle. And if we are able to find, if we are able to detect a defect or a problem in early phases of software development life cycle, then our cost of correcting those errors is lesser. If we find an error in the later stages, the cost of correcting the errors is very high. Third one, and the major reasons, this is actually, I should say, the most important reason for testing. If your software is untested or some part of the software went untested and you delivered the software to the user started with the software, but software had some errors, this could make that company fail. This could cause that company failure. Some tests, some errors are too big that the whole of the company can collapse. This is very, very important. Especially testing is important for your healthcare equipment. If you are making the software, for example, look in this picture, it shows the patient's monitoring values. If the software of this machine, for example, imagine that's not that correct, it has some bugs or it has some problems, think what can happen. The patient life will be at stake. Similarly, the military systems, they involve very high risk of human life. If that software it has some bugs, it can take human lives also. Very, very critical. In testing, some of the efforts that you were introduced in the previous chapters, they were review and inspection. These techniques are good. We are using it, but those techniques are not enough because these techniques were used before the program was executed. But now we are targeting the flaws or bugs when the software is running. Very simple example is you cannot test a car without driving it. You can have a look at it. Some of the problems, some of the defects you can identify before driving the car, but the actual problems you will be able to find it out only when you are driving the car. So basically, we are targeting identification of the errors when the program is running. Here in this slide and the next slide, you will see some of the examples of the companies that got failed due to bugs in the software. A company named Bloomberg, in April 2005, Bloomberg terminal in London crashed due to the software glitch which affected more than 300,000 traders on the financial markets. So big, drastic effect. And it forced the government to postpone a £3 billion debt sale. Second example, Nissan cars have to recall over 1 million cars from the market. 1 million cars from the market due to the software failure in airbag sensory detectors. Very small software, but very important for the human lives. It had a failure, it had a bug in it, and Nissan had to get back its 1 million cars. So big loss. This failure of the software bags, it was reported during the accidents, actually two accidents. And then they found it out that the airbag is not working. Then they found it out why it was not working. It was because of the software of the sensors. Uh-oh, big loss. They had to get all the cars back. Third example, Starbucks. You are all aware of. Starbucks was forced to close about 60% of the stores in the US and Canada due to software failures in their point of sale system. Yani the system through which they were getting the cash, it had some bug, it had some failure, and due to which they had to close 60% of their stores. Big loss. Next example, Amazon. You are all aware of Amazon. Some of the Amazon's third-party retailers saw that their product price is reduced to 1 pence due to a software failure in Amazon software, a glitch in Amazon software. Their price was reduced to just one halala. Their currency is dollars, so they have pence, and our currency is real, so we have halalas. You can think that the pence is like halalas. So 1 pence, it was reduced due to software failure, and they were left with very, very heavy losses. Some more examples of software failures. There was a vulnerability in Windows 10. This bug enabled user to escape from security sandbox through a flaw in Windows 32 Win32K system. So it means security was at a very high risk. In 2015, the fighter plane F-35 fell victim of a software bug, making it unable to detect target correctly. Uh-oh. If a plane is not finding the targets, detecting the targets correctly, it means it's not working fine. It means it cannot fight. Another example, China Airlines Airbus A300, it crashed. Uh-oh. A lot of human lives. The 264 innocent lives. It took the airplane crash. It took 264 lives in 1994 due to a software bug. See how big can be the losses. Similarly, some more losses are here. So of military satellite, of US banks, which caused this software bug in 1996. There was a bug in the software which was handling the bank accounts, and it was handling basically 823 customers. They were affected by 920 million US dollars, a lot, big loss. So the purpose of showing you these cases of software failures due to software bugs, and of course if software failed, it means the testing was not done properly and it crashed in its actual environment, or it had some bug, or etc. And the losses were huge, you saw. That highlights you the importance of testing, how important it is. So a software, before it is delivered to the customer, must be checked thoroughly, must be tested thoroughly. Next question is, how is software testing done? Software testing can be done both manually as well as using automated tools. Yani you can design your own software test cases, or there are automatically available tools. You can use those tools which will test your software. When you are doing your testing manually, it includes several points. First, it includes requirements verification, that you verify your requirements, have all the requirements been met. It includes development of test strategy and plan. Before you doing testing of the software, you should make a whole strategy and a complete plan how and what part of the software, how you will be testing each part of the software. Then you prepare the test cases, then you execute the test cases, then the bugs or the defects are identified, then you fix those bugs, then you test them again to ensure that those bugs were fixed. And finally, the test report sharing with all the relevant stakeholders. The second approach, where you might be using some automated tool to test your software. That testing is called automation testing and includes the tools that you will be using. They have scripts. In those tools, basically you prepare some of the scripts and then those scripts will be run. Basically, those tools help you in running your scripts where you mention different types of your test. And then those tools generate reports of the testing for you. The examples of these tools are Selenium, Catalan Studio, QTP, and many, many more tools. Some of the tools I will be showing you inshallah in next slides. What are major types of software testing? There are two major types, two major aspects of the software that basically you are testing. You are testing the software for its functions, called functional testing. Here you check the business operational requirements. And second type is non-functional testing. As you already know, that the non-functional testing, those are all other aspects of the software which are not the direct requirements of the business operations, but of course those are very relevant and very important for the performance of the software. The functional test types, those include unit testing, integration testing, system testing, user acceptance testing, sanity, smoke, interface regression, and many more. Here, inshallah, in this chapter, we will be focusing only on the first 4 functional tests that I have highlighted here for you. That is unit testing, integration testing, system testing, and user acceptance testing. There are many more functional tests, but it's not possible to cover them all in one course. Actually, this testing can be a full-fledged course itself. Now here in this course 250, we are studying it as a part of a course, but it is so wide, so huge, that a separate course, I think it might be even not enough for completing this topic. So here, as you would have seen, that the title of this chapter was Introduction to Software Testing. And I saw, when I was preparing these slides for you, I saw there are many online courses on software testing. If you are interested, you can go and have a look at them and do some certifications also, if you want to stay in the field of software engineering. Many people, they have done their PhDs in software engineering fields, so it is very, very popular. In non-functional tests, some of the types of non-functional tests are performance testing, load testing, stress testing, volume testing, security testing, compatibility testing, recovery testing, reliability, usability, compliance, and many more. What are the major functional testing that we are going to study in this chapter? These are called unit testing, integration testing, system testing, user acceptance testing, and regression testing. Actually, I think regression might not be the part of this course outline, but anyway, we can see, inshallah, no problem. Okay, so the major functional test, as I said, these include unit testing, integration, system testing, user acceptance test. Here is a brief description of these testing. The detailed description of these testing is coming in the next slide. Unit testing, it targets at individual modules, individual functions, and individual classes. Of course, in your software, you would have classes, modules, functions. So you are testing each and every module, each and every function in each and every class. After you have checking each individual components. So unit means individual components. After unit testing, any individual component testing, look at this picture. The next phase is integration testing. Yani you are putting individual units together, they should function in an integrated form. So in integration testing, you are checking their interfaces, how the modules are interfacing with each other. If they come together, they work together, of course. Are they working fine with each other? Interfaces means one module is calling the functionalities of other modules. One class is invoking the method of another class. Are they working fine? Are they, when they are put together, they are calling each other, they are taking the services of other classes, other modules. Are they working fine in an integrated way? That is integration testing. So in integration testing, we are checking their interfaces. After integration testing, the next phase is system testing. In system testing, we are checking the whole system together. There are two major approaches of system testing. We will see inshallah next. The last part is acceptance testing. Actually, it is user acceptance testing. In user acceptance testing, we deliver the software to the user, we install it, and it is in production environment. Initially, of course, slowly it comes into the production environment. User checks it. After user checks it, tests it, performs all the operations, they tell the company who have developed the software that okay, we are satisfied with it. They accept it. That test is called user acceptance test. This picture on the right hand side, it shows how the workflow of testing it goes on. What is the workflow of software testing? Okay, here is your main software, the source files where you have written the code. Here is your test cases. Yani you decide the input data, you decide the conditions and all other set of variables. Those are mentioned here in the test cases. You write them down. For all those, you prepare several different test cases. For each of these test case, you execute it on the source file, you input it, then perhaps sometimes you have to recompile it. Sometimes you don't have to recompile. Okay, if you need to recompile the whole code together, you recompile it. Then you run the test, you run the software, you execute the software, and you see the output results. If this output results, it matches your expected output or it satisfies the requirements, then the test is done. You test the next test case. Again, in the same way, then the third one, then the fourth one, and all the test cases are done in the same way. It should be noted, important to note that sometimes you do not need to recompile the code. If those input files are not used in the compilation of the source files, then you don't need to recompile the code. So this step 2 will be skipped. Okay, let's go into details of this type of test one by one. Our first type is unit test. So in unit test, you are checking each individual component, and each individual components are your individual modules. Inside the modules, your individual classes. Inside the classes, your individual methods. So we are showing here a very, very small component, that is the function or a method inside a class. Then the class will be tested. Then the whole module in which that class was being used, that will be tested. How we are testing the function? Of course, we write a piece of code that will test the behavior of the function, then behavior of the class, then behavior of the module, and that test is called unit test. So unit test is a piece of code which tests the behavior of a function or a class or a module. Unit tests are written by the developers because developers, they know that what are the classes they have made, what are the functions or the methods they have made inside the classes, so they write the code for the testing the functions. Here is an example of unit test. For example, you have written a software for a calculator, and inside that software you wrote a function for adding two different numbers. In unit test, you will check, is that addition function working fine? How will you be doing it? You will input, for example, this addition function, it takes input as an input two number of variables. Two variables, number 1 and number 2, are given as input. Then this should perform its functionality and it should give you addition or sum of those two numbers. If that sum is correct, you will say that this addition function is working correctly. That is a very simple example just to introduce you how you are doing unit testing, how you are doing function testing. You know, if this is the input, that should be the output. In unit testing, the function used in application and then test it with the application. First of all, you will be testing it separately, then you will test it alongside in the context of the whole application. What are the automated tools for unit testing? As I said before, that your developers, they will write the code for testing the units, individual units. All right, fine. They can do the unit testing manually. Are there automated tools as well that can do the unit testing? Answer is yes. What are some of the tools which are widely used for unit testing? Some are here. For example, Jasmine, Mbunit, NUnit, Simple Test, HTML Unit, TestNG, JUnit. This is for Java, writing the unit test for Java, and many more, but these are the important ones. So once you are writing your code, you should do the manual test as well as you should use automated tools. They will do the unit testing for you and they will generate the testing reports which you can later share with the all stakeholders. Next testing after the unit testing is integration testing. Integration testing is performed to check the interaction between different components of a system. There are different components usually which have been written by different software teams, different software developers, because the software is very big and the work is divided among the software developers. They make their part of the code, make their part of the software, then those components are put together, and then the interfaces of the softwares, for example, in this picture, this is symbolic representation, it's not a software, but you will see from this picture you can understand that the interfaces, only the interfaces of the components, individual components, they are checked whether they are working fine with each other. It means when you are integrating different components of your software together, you are testing them, testing the interfaces if they are working fine. Individually, you would have done the unit testing. Now putting them together, you want to check they are working fine with each other. That's the integration testing. In integration testing, basically individual units are combined and tested as a group, not individual testing. See this picture once again, this is the symbolic representation. Now this component would have been tested in unit testing. This would have been tested in unit testing. This would have been tested in unit testing. Now you have put them together, run them together, and see if they are working fine as a unit, as a group. Similarly here,